Hello guys, so today I am going to discuss with you linear regression. We will see how to apply it in Jupyter Notebook. Okay, so our data set is about bike sharing and it is taken from UCI website, and here are some of the important things about the data set, like it is of multivariate, feature type is integer and real numbers. The subject area in which the dataset is made is on social science. Number of instances is about 17,300 and total features is 30. And as I will discuss it about linear regression, so obviously I will choose a dataset which is about regression. Okay, regression means continuous values. Now, what the dataset is about? The dataset has many features like date day. Okay, like it gives like date day contains the date, season which season, let's see, one for winter, two for spring, three for summer, etc. Year, there are 2 years, 0 for 2011 and 1 for 2012. Month for 1 to 12 number, hour is from 0 to 23, and holiday, here is a description whether day is a holiday or not, extracted from, okay, the source is given and that is not important. Weekday, day of the week, like 1 to 7, no sorry, 0 to 6. Working day, if day is neither weekend nor day, is 1, otherwise it is 0. And weather sheet, -1, clear, few plus, partly cloudy, partly cloudy. Here are some additional information, like for the weather sheet it has given us -1 which stands for clear, 2 for mist, light snow and heavy rain, and other are there like what is the size of this file. Okay, now we have to we can download the data or we can import in Python. Okay, so as I click in import in Python, first is install the UCI ML repo package. So just you have to pip install it in the command prompt. As I have done it previously, I will not going to show it. Then we have to import the dataset, just like copy the code and you will be good to go. So as you can see, I have already created my so what I do is I actually run the Jupyter Notebook in VS Code, but you can run it in Anaconda or Google Colab, that you are free to use. Okay, now I have just copied the same code which was present here, and therefore when I will run it, so I will again running it in front of you. Okay, so let's just wait for a few seconds. It is taking time. Okay, so it has completed the running, and here it gives the some like description that is no of use. What we have, what here is important is x and y. Okay, so x contains the independent features and y contain the dependent feature. Okay, so first we will run what are the column names like date, day, season, year, month, etc. So let's run it. Sorry. So let's just run it, print x dot columns, and of course I want to see what are the column names present in y. Then I have printed the I want to see what values are present in the season and the year. Okay, and in the year I want to see how much, like 0 stands for 2011, if you remember. Sorry, if you remember, 0 stands for 2011. So in the data set 2011, like the number of features that were present in 2011 are 8600 and 2012 is 8700. Then I want to create a like I want to create a data frame which contains both the independent features and the dependent features. Okay, so therefore I create a data frame, and in this particular code snippet, what I am trying to do is, like, I want to see how some of the features are dependent on the count, or I will put it as simple. What is the scatter graph of temperature versus count? Okay, what is the scatter graph of like humidity and count and wind speed versus count? So if I run it, you can see. So yes, it has given the graph. So it is the scatter graph of temperature versus count. As you can see, it is a little bit of linear dependencies there. But here also we can like what I can say, uh, mm, like not so much of linear dependency. And here the linear dependency is almost zero. Okay, here also it is zero. Now, so one type of way is to you plot the scatter graph of the interdependent versus dependent. Other way is to like check the correlation. Okay, how two variables are correlated to each other. So that's why I have like printed the correlation matrix of like the data frame. So as you can see, season and where was the count? Wait one second. I guess. Okay, let's just see. Season, like year and season are correlated like minus 0.01. Hour and season are correlation is 0.06. But as this table is fully confusing, I want to create a heat map of the correlation matrix. Okay. So here is the code snippet to create a heat map, and here you can see like season with season is obviously there will be high correlation of 1, and season with, let's suppose I catch up this value, season and temperature, there is a small correlation. Okay, 0.31. Okay, now the main task of the correlation heat map of the correlation matrix is we have to pick up the features that are like lowly correlated to each other. So we have to take the features that are not highly correlated to each other, okay, for doing the linear regression. As we can see, the count variable is here, so this particular column is of useful. And we can see here we have to pick the correlation values that are not highly correlated each other. It means that the correlation value is not near to 1, okay, or minus 1. As you can see, these four values are of useful, and particularly the hour value is mainly useful because it is of 0.339, like not so much correlated. Other good feature is 0.4, that is temperature, much like less correlated with the count. And another is humidity, 0.32, like not much correlated, but as its mod of the correlated value is 0.3, so it is much of good use. So like this I have picked up 5 features that are not much more correlated, like not much more or not much less, okay, like mediumly correlated to each other, that will help us in linear regression. Okay, so what I have done is like we have dropped the other features that are not present here. Okay, and here is the code snippet of the linear regression. From we are using sklearn, the package of the Python, and from linear model we are importing linear regression. And obviously we have to divide the dataset into train and test parts, and we have also imported some metrics like R2 score and mean squared error to see how much our model performs, or to see how our model performs. Okay, so R2 score will give us if R2 score range is always from -1 to 1, let's suppose its value is 0.35, so it means that model correctly predicts only 35% of the data, and mean squared error gives us like a value which if the actual value is y and the predicted value is x, so mean square error will give us like how much x is distance to y. Okay, so and then in this line we have just divided the data part, and then we call the fit function, and then we call the predict function, and in the next step we calculate R2 score and mean square error. So I will run it. So R2 score is 0.38. So only 38% of the data is like the model is about to predict, and 1962 is the mean square error. Now when I will take the root of this 1962, then it will give how much value the predicted value is far away from the actual value. Okay. So as our accuracy or performance in this model is bad, we will shift to like polynomial regression. Okay, what we'll do, we will like in this scatter graph, what we are doing, we are like putting a linear regression or a straight line. Now we will put a curve on it. So let us see what we can do with a 2-degree curve, or well, a 2-degree polynomial. So here as you can see, mm, no, in this particularly code snippet, I have only like applied standard scalar to extend and x test. Okay, so like uh, we are putting the numerical values in some range such that the standard deviation is 0 or the mean is 0. Okay, so it is useful, and as you can see, it is not helping with our accuracy or R2 score and mean square error. And in this particularly code snippet, I have created a like I'm trying to fit a curve in the scatter plot of degree polynomial 2. Okay, we are trying to make a model that is of second degree polynomial. Okay, then simply I have transformed the data and just call the linear regression. Okay, and as you can see, our model performs a slightly better. It is now predicting 52% of the data. Okay, then I have used degree equal to 10. Okay, then it gives 0.68 of R2 score. Like our model correctly predicts 68% of the data. Okay, and as you can see, mean square error is also becoming less. First time it was about 19,000, second time it 15,000, and in degree equal to 10 it comes to like 10,000. Okay, and when we use like something like ridge regression, so what ridge regression does is like it adds some what I can say, add some parameter to our cost function of the linear regression, so that our data is protected from the outliers. So I will take another video, or I will record another video of what are the outliers and how we can fix that in the next class. Meanwhile, uh, with using the ridge regression, our R2 score has not so much improved, but as you can see, our mean square error has improved. Okay, so this much was today, and I will continue to upload the videos on machine learning. Thank you so much. Goodbye.